So in this class, we are simply going to have a continuation actually from the resultant velocity. We managed to work with a lot of things on our resultant velocity. Even though we did not consider or talk much about these velocities of boat and current, where we have a boat and a current. So when I'm referring to a current, I'm simply referring, guys, to the continuous movement of water in a specific direction. It's actually the water that we are talking about there. So it describes the flow of water from one place to another. That is a current. All right. So a current that I'm referring to, guys, this one, it refers to the continuous. All right. So it refers to the continuous movement. All right. So it is the continuous movement of water, continuous movement of water in a specific direction. All right. So, all right. Let me just finish here, guys, so that we can talk much about this current that we have there. So it must be in a specific direction. So it actually describes the flow of water from one place to another. That is the case there. So it describes, all right, the flow. That is the flow of water, from one place to another, from one place to another. So if you consider this, it is important, from one place to another. If we are considering a current, this continuous flow of water, in our resultant velocity, remember we had a condition actually whereby there is a condition, maybe let's consider previously when maybe there's a condition of an aeroplane which is going like this, then there is a wind blowing, all right? A wind is blowing, so we end up saying, okay, this wind, we just have to extend that wind and see it there like that. But in this case, we must be careful. A condition like that, it is there, it exists, yes, but mostly we are going to have the first condition when the current is flowing in the direction given. All right. When a current is flowing in the given direction, is flowing in the given direction, in the given direction. When I'm saying the given direction, guys, the exact direct that you're given, the exact one, the exact to say it is flowing in this direction, in that direction that you're given, the current is flowing in this direction, that direction that you're given is the one that you are going to be working with. Not when they say from a certain direction. That one is another part. Yeah, it's flowing in that given, that in the given as it is. There is no from there. The from is not there. The word from is not there. So in that case, you take or you use the direction of current as it is, and that of the boat as it is. Okay, so this is what I'm trying to say. You use the direction. Okay, so let's say this is your north, your south, and so on. And the boat is going this way. All right. So let's say this is your boat, which is at a certain velocity that you are using, and this is the angle that is affecting the boat. All right. Then on your current, the current is going this way. All right. Or maybe the current is this way or that way. Whatever direction that you have of the current. All right. Let's say this is our current, which is taken at a certain angle, you'll be given that angle that you'll be having. When it is flowing in that given direction, guys, you use the given direction as it is and use your components or whatever method that you are capable of. All right. So use the given direction as it is. Use the given direction as it is, in that case, as it is. All right, as it is. So you're going to apply your components, whatever that you use there, apply components. Oh, guys, you know your components. So I actually have a video that I've worked on the coplanar forces. On the coplanar forces, use of horizontal and vertical components. So make sure that you watch that video. It is on the playlist for Engineering Science N4 and also Engineering Science N3. So that, guys, you know, when you are dealing with components, it will be, we end up having a lot of explanations which are not even necessary. It is because of that. So now I have a video which is separate. So if you want to learn more about the components, go there and check so that we do not have a lot of questions. This time, why did you use this angle? Why did you? So I made a video, guys, to explain all those questions that you wanted to know on your components. Actually, on the components, yes, just components. All right. So this is it. You're going to use the given direction as it is, whatever that you have there, the current as it is, there is no changing of why there is no as it is, guys. You apply your components, you're done. You know your components, you need horizontal, vertical, then also the resultant. So that is the first condition that you will be given when it is in that direction. That so we're gonna see questions and also how to apply our components, guys, this and that. The second one is when the current or when a current, all right, when a current is flowing from, all right, is flowing from, this is the most important part here, from a given direction, from a given direction, from a given direction. So let's say we are given a case. This is the example that I actually did in the resultant velocity video. Question number 3 on those questions. It was from. So you saw that you saw as if it was maintaining what I explained about the resultant velocity. When it is of this nature, it is because of that. It maintains the way that we're working all those resultant velocity when a wind is blowing, this and that. It maintains that. This is the condition that maintains what we explained before on our resultant velocity introduction. This question, when a current is flowing from a given direction, let's take for an example, e.g., it is flowing from, then we are given a certain angle. Let's just give an example, guys. Let's say north theta degrees to the west. I'm just going to give, let's say, okay, let's put it here. This is our north. This is our south, our west, and our east. Okay, the boat will be originally in its own direction. Let's say the boat is going this way. So the boat, remember, it maintains whatever that it will be having. All right. Let's say this is the boat. But the current now, this is the current. Remember, here we're focusing on the current, the flow of water that we have. So the current is flowing in the from, not in this direction, but from north theta degrees to the west. It means something like this. So it will be like this, somewhere here. So it's like this, guys. It will be flowing from this direction, from. Guys, take note from. From is where you are starting. It's like you're starting from who. So you're starting from here to where? To where? That is the question. Because we are saying it's from here to where? Where is going to be our final direction? To the continuous path. You continue with it to the other end or to the other quadrant there, like that. So it's going to just continue like that. Exactly the condition that we had previously on that case of a wind. When a wind is blowing like this, remember I said you ignore this part, you continue with it to the other side. This is the exact condition that we are working with. From it ends up to this side, that is where it is going to be. This is your what? Your current. This is where we are going to have our current at. So what is important is for you to know the angles that you're going to use. Guys, I talked about components on the introduction, so it's up to you. Are you going to be working with the reference angle? If you're using the reference angle, you must have the reference angle between what? This one of the boat. You must also have the reference angle for what? For this one of a current that we are having. So this one of a current definitely you must work it from that one of both. If you extend it like this, guys, remember those vertically opposite angles, this and that. So apply those vertically opposite angles. You're now back to your mathematics. It's no longer about engineering science, guys. It's back to your mathematics. But these are the two conditions. It is flowing in that direction that you're given as it is. When it is flowing in that direction, you maintain as it is. It's not going to change to say it is flowing to, then you change. No, 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 no. You do, I mean, you have it, or when it continues like that in that manner, when it is flowing from a given direction, just like a wind is blowing, those conditions of a wind. So everything, guys, in your calculations will remain the same. Whether you're calculating displacement, remember that your displacement is equal to a displacement, that's velocity times time, where the velocity that you use there is the resultant velocity that you have calculated. So depending with what you're given, if you're using meters per second, the time must be seconds. If you are using kilometers per hour, the time must be what? Must be hours. So there, in terms of the units, guys, you are now back to your mathematical units that you know, guys. All right. So these are the two conditions. So I want to use these examples quickly. We're not going to waste much time, guys. Resultant velocity, we talked about it. It's just a continuation. So do not change anything, guys. The formulas, calculating of the components, everything, nothing has changed. But only that the type of questions. Okay, let's see this one. They are saying here a ship that cruises at a certain speed, right? At a speed of. So there is a ship there. All right. So it's gonna be at this speed in still waters, sets south westerly course. It is driven off by a current flowing. Take note, it is flowing in that direction, not from that direction. It is flowing 28 degrees west of what? Of north at this speed. Calculate the resultant velocity of the ship. Take note, guys, on this type of a question. Because you say, we did resultant velocity with the say, and you are saying, when it is like this, you continue with that one, you see it on the other end. No, there are questions which are like that. They are the ones which are not like that. So this one, it is flowing in the direction given. This is the original direction as it is, guys. When a current is flowing in the given direction, it is just maintaining its direction here. It is not from this. This is its direction. Take note, guys. This is its direction. So take note. So according to our information, let's just take note. So you got a ship, which is at a speed of what? 30 kilometers per hour. Then it's southwestly. So that is the course that we have: southwest, southwest, southeast, northwest, northeast. It means in between there's an angle of what? 45 degrees. So they are simply saying south 45 degrees to the what? To the west. That is the southwest. If you're not given the angle will be what? 45 degrees. That one, you know, guys. All right. Then a current. Let's talk about this current. So on our current, what is the speed? Take note, this is its speed, 16 kilometers per hour, but the direction of flow, flowing in this direction, 28 degrees west of what? West of north. What does it mean? What does it mean? If you're given this statement, guys, be careful. Theta degrees, let's say west of north, as we are given there. West of north, it means north theta degrees west. We are starting from, it's a movement. We are moving from north to west. So it's north theta degrees to the west. That is what it means. Theta degrees west of. So if it is a theta degrees east of what? East of south. East of south. East of this. We are starting from the what? The south, going to the east. So it's south theta degrees to the what? To the east. That is what it means. Guys, know these things. They are very, very important. So in our case, they are saying what? It's 20 degrees, 28 degrees west of what? West of north, west of north. So it means north 28 degrees going to the what? Going to the west. This is for our current. This is for our current now, this one. So I want us to be very, very careful with the information. Information is important. So this is for our current. So the question was to calculate what? The resultant velocity of the ship. This one, it is maintained. This is its flow. This is the flow of current, this one. Original flow of what? The original flow of current as it is, the direction as it is. There's nothing that has changed. It is not from here. That is its direction. So what it means, guys, is that you are simply going to have this as they are. As they are. This is our north, remember our south, west, and our east. So the ship south 45 degrees west, southwest, southwest, in between. It's in between south and west, in between. So it's 45 degrees here, 45 degrees here, in between, guys. That is what it means. All right. So it's going to depend with which angle are you going to use on your components. All right. Are you going to use the reference angle, or are you going to use the actual angle from what? From the positive horizontal axis? It's up to you. All right. So this is our ship, 30 kilometers per hour, 30 kilometers per hour. Then the current as it is, remember this is its direction of flow, so nothing has changed. North to the west. From the north going to the what? To the west. This is the direction. From the north going to the west. So it's going to be like that. So this is our current. It is going from north to what? North to west at an angle of 20 degrees. That is 16 kilometers per hour. Just like that. So this is your what? Your current, this one. This is our current. According to our concept, it is in that flow. So it maintains its direction as it is. So if you are using components, guys, like I said, I have now explained a video which is separate. It is up to you. Are you going to use the actual angle from the positive horizontal axis to the given what? To the given speed, this one. Are you going to use the actual angles? If you are using the actual angles, you add as they are. You do there are no subtractions there, guys, to say I'm on the negative side. It's gonna carry a negative, or it's gonna carry what? That is when you are using what? The actual what? Actual angles. But if you are using the reference angle, like I said, guys, the reference angle, on that condition of the reference angle, you must consider, remember, this is the acute angle between the force or whatever that you be given and what? And the horizontal axis like this. These are the reference angles. There you must consider to say, is my horizontally negative or not? So you must consider that. So I'm not going to explain much, guys. I've explained in a different video. I'm going to use the reference angles. So using the reference angles, I'm going to need this angle between what? The horizontal and this what? And this current. So from 90 degrees, we know this is 90 degrees, guys. So that's 90 minus 28, which is 62 degrees. So this angle is what? 62 degrees. So if I'm using reference angles, all right, so when using reference angles, so there I must consider properly to say my horizontal component, which side is it? Horizontally, left side, they are what? They are negative. On the right side, they are what? Positive. So they are going to carry negative because we can see that we are on the left side. So it's going to be what? Negative 16 cos 62. All right. Then we consider 30. That's negative 30 cos 45. The angle between horizontal and the ship is what? 45 degrees. So that's cos 45 degrees like that. This is when you are considering what? The reference angles, the acute angles. But let's say you're using the actual angles. You are going to take as they are the whole of this angle, this one, which will be 90 plus what? 90 plus 28. You take the whole of that angle. All right. You move on to another part. the whole of this angle, this one, which is going to be 180 plus what? 45. You add them. There are no negatives there when you are using actual angles. So guys, make sure that you watch the video of using actual angles. So that's it. If you are using the reference angles, also watch the video, guys, so that more explanation will be important. So that was going to be negative 28.725. All right. 0.725 horizontal being negative. All right. We've got negative, positive. So negative is what? West. So meaning to say our horizontal was 28.725 kilometers per hour. So this is kilometers per hour, but being negative, we said we are going to the what? To the west. So that is the condition of that negative. It is simply telling us the direction, nothing much. The direction, I mean, where are we going to have it? Is it to the west or what? All right, then we move on. Still on these components, we're going to need what? The vertical. So we need the vertical components, carrying sign. And using the reference angles, we must consider where that vertical is. Is it positive or negative? According to this one above, we know that vertical is what? Positive. Down, it's what? Negative. Okay, so we must consider when you are using these reference angles. So it's 16 positive, 16 sine what? 62 degrees. Then the 30 is going to carry a negative, negative 30 sine 45. Okay, but if you are using the actual angles, guys, there's no need of you putting a negative there. You just take them as positive as they are. All right, so that's it. Your vertical component was going to be negative 7.086. So if you're using the actual angles, guys, you must have the same answers, just like these ones. Same answers. Vertical being negative, it means we are down there, south. So our vertical component is 7.086 kilometers per hour. That is considering to say it is going to the what? To the south by being a negative. So that is it. Using our components, guys, I said the west and the south that we are seeing here will help us now on the resultant to say which quadrant are we going to have where these two are found. We only have one quadrant which consists of the west and the south. Okay, so this is north, south, west, and east. So where do we have west and south? West and south here. This is the part where we've got west and south, or where our horizontal is negative and also our vertical is what? Negative. So in this quadrant, our triangle, remember how you draw your triangles? Your triangle will be like this. Okay, so 90 degrees here. This is the horizontal. You can write the negative or you can even leave it like that. It is just to show us the side, this one. It is not important on your calculations. Same as the vertical. You can just write it as a positive 7.086. All right, so that's it. Let's calculate this R and also our direction, which is the theta, this angle in between here, this angle theta. From west to what? To south. Or you can use the alpha from south going to the west. You can call this one alpha. It is up to you. All right, just like that, guys. You're done. Just like that. So that is it. Let's calculate our resultant. Remember, that's the square root of horizontal component squared, vertical component squared. So that's it. Horizontal, 28.725 squared plus the vertical. Remember, guys, I said there's no need for even you writing those negative. If you want, guys, you can write them. No problem at all. It is not a problem at all. All right, so that is the case. So I want you to combine these on your calculator. That was going to be 29.586 kilometers per hour. Remember the units. Then definitely we'll need what? The direction, theta. All right, our theta from arctan, as we do understand, it is opposite and what? Adjacent concept. So this is arctan of what? Vertical, which is opposite 7.086 over what? The adjacent, which is our horizontal, 28.725. All right, ignore the signs, the negative that we had there. Just use these as what? Positive values. So that was going to give us 13.857 degrees, just like that. So according to this theta, we are moving from where? West going to the south. So it means, therefore, in our presentation, we were going to have our resultant velocity, therefore, was going to be what? 29.586 kilometers per hour. At this direction, from where? West to the what? To the south. West going to the south. And another thing, guys, there's no way that your triangle is between west and south. Then your answer is carrying south and east, or your answer is carrying west and north. That one does not even exist. That one, it will be a mistake. So it can be from the question paper. That would be a mistake. It can be from me, guys. That would be a mistake. If you see something like that, you must indicate that one. You must talk about that. You must comment about that thing. Let's see. Once you are in these where there is west and south like this, those are the letters that you're supposed to see on your answer. You're supposed to have west and south. It's either you're moving from the west to the south or from the south to the west. That will be the only condition. We will not gonna have southeast in that quadrant, or north west there, or south to whatever. It will be in within these two. So from theta, that is west to what? To south. So that one, it will be west to what? South. West 13.857 degrees to the what? Going to the south this way. Or we are moving from the south going to the what? Going to the west. But if we take that one of south going to the west, we must use the angle, this one alpha. So we must find alpha, where alpha is the angle, this one. In between this, there's a 90, I mean, the whole of this one, the whole of this is 90 degrees. So how do we find alpha? We simply have to remove this one from what? 90 degrees. So alpha is 90 degrees minus theta. So that's 90 degrees minus 13.857. That was going to give us our alpha in that case. All right, which was going to be 76,143 degrees. So you can write it as south 76.143 to the west, from south going to the west. That is the other way only that you can write, not to say from south to east. It only happens when you are in that quadrant. Those are the poles that you're supposed to have. You are in this quadrant where there is west and south. Let those ones be part of your answer only. So that is what you have, guys. So you can have our answer with this direction, or we can have our answer. Remember, I said it can be what? South 76.143 to the west. You can have it like that. Okay, so guys, do your revisions as much as you can. Engineering science N4 is actually a lot, because that is the last stage, remember, of your engineering science. So definitely they will need you to apply a lot of things, to know a lot of things actually. Yeah, so let's just try to understand that also as students, as we are doing our revisions. Let's just try to understand that this is the final stage. So there will be a lot of things. You'll see that a lot of applications, a lot of things that you need to learn. And with the time frame that you have, you won't be able even to learn, to understand. But let's just learn to pass, and the understanding, you can even do it on your own, guys. After you're done, you are just waiting for your results. You can now start to learn the concept within those weeks. All right. Anyways, let's see 4.2, the distance the ship has traveled after 3 hours. So what will be the distance? All right. So in this case, guys, remember I said on the formulas, displacement, distance can be calculated from what? Velocity times time. So sorry for that. So meaning to say, on 4.2, our distance is simply the velocity times time. So the velocity that you use is that resultant velocity that you calculated. What is your resultant velocity? The time you're already given. Our time is what? In hours. This resultant velocity, is it in kilometers per hour? It must be in kilometers per hour. So remember our resultant velocity here and also its direction. You are going to use its direction for that distance, right? So you're going to consider, or just this part, this is your resultant velocity, guys, which is what? 29.856, all right? 29.856. So this is the case. So we're just gonna multiply. Sorry for that, guys. This one just gonna multiply because we have a lot of information there. So remember, it was 29.586. This was kilometers per hour. So you must use the time in what? In hours. So our time in hours is what? 3. So you're going to multiply by what? By 3 here. So that's our S, which was going to be 88,758 kilometers. That's our distance. In the same direction as that velocity. Remember, our velocity was moving westward, 13,857 degrees to the south. Same as what we had on the what? On the resultant velocity. Remember, you're using the direction of what? The resultant velocity. So that's how you can answer your question, or you can just leave it like that. They will still give you the full marks there. So this is how questions might be given as. Question number 5, we've got a similar situation of a current. So there we are given that a ship cruising at what? 80 kilometers per hour in still water sets course. All right. Southeast, that is the way that it is moving in the southeast. It is driven off by a current flowing. This is the direction that is flowing at this rate, at that speed. Is it flowing from this direction? No, it is flowing in that direction. It is maintaining that direction. So it is the same as our previous question, guys, this one, as it is. So we're going to take our ship as it is, 80 kilometers per hour. In still water, then this is the southeast, the direction. Southeast, remember I said it simply means south, 45 degrees to the east. Then the current, our current in this case, as it is flowing in that direction at 15 kilometers per hour, east, 12 degrees to the what? To the north. So the question on A was to calculate the resulting velocity in magnitude and direction. So this is the direction of current, guys. This is the direction of what? The direction of flow as it is. Nothing has been affected in our flow to say we are going to start from this. It is exactly moving in that way. So in this case, we won't have any effect, guys, just like our previous question. You'll see the effect on the next question. So here, let me just quickly have this one. So this is it, guys. North, south, west, and our east. So here, the ship south to east, southeast, that is in between southeast at what? At 45 degrees. So this one will be directly at 45. So let's say this is 45. It means also this one is going to be 45. As for me, guys, I just going to use this one. I'm just going to take this 45 here. All right. So this is our ship. 80 kilometers per what? 80 kilometers per hour. 80 kilometers per hour. All right. Then the current, 15 kilometers per hour east, 12 degrees to the north. This is the direction of as it is. East, north. East, no, between east and north, like this. So this is our current as it is. All right. As it is, guys. As it is. So that is east going to the east, going to the north. Going to the north. So we are attempting to go to the north from the east. That is what it means, from the east. So this is our 12 degrees and the speed 15 kilometers per hour. So this is 15 kilometers per hour as our current, just like that. So with our components, guys, we can calculate the resultant. No adjustment to be made on this type of a question when it is like this. It is in that flow as it is. So like I said, we're going to see the last question, which is the one that has an effect. All right, so horizontal component, in this case, I'm going to use, guys, the reference angle. Remember, the reference angles, those are the acute angles. The acute angle between what? The speed and what? Horizontal. So I'm going to use this, and using this, I'm going to consider to say horizontal to the left. Horizontal is what? Positive to the left. So all these will be positive in terms of horizontal. So that's 15 cos 12 plus the 80 cos, that's 80 cos 45 degrees, just like that. So let's take this all together. That was going to give us 71.241 as a positive. That's kilometers per hour. And being positive, horizontal, it means we are going to the what? To the east. So that is to the east. All right, then the vertical component, still working with the reference angle. The vertical here on top, it's positive. The vertical down, it's what? Negative. So that's 15 sine 12 degrees as a positive, and minus this vertical, it's in the negative region. So that's negative 80 sine of what? 45 degrees. If you're using any other way, then that is up to you. You can use the actual angle, the 12 as it is, then the other one from here to here like this, 360 minus 45. You can use that one. But make sure that if you're using actual angles, you just add. If you're using these reference angles, these acute angles, you must consider where is the vertical? Is it in the negative? Is it in the positive? All right. So that's it. Negative 53.45. Vertical, negative. We are going to the south. So that means it is 53.45 kilometers per hour in the south, going to the what? To the south. So that is the condition. With this, we can determine our resultant and also the direction, because we just need the quadrant where we have the east and the south at the same time, or where horizontal is positive and the vertical is what? And the vertical is negative. Which quadrant is it that we have the east and the south at the same time? So this is it, guys. North, south, west, and east. So east and south at the same time will be here in the fourth quadrant, where horizontal is positive, vertical is what? Negative. It's in the what? Fourth quadrant. Just like that. Horizontal, you take your answer, 71. This is what? 71.241. Vertical, 53.45. The negative, guys, do not worry about that one, just like that. So that's it. We can calculate our resultant R there, the square root of horizontal squared, vertical squared. 71.241 squared plus 53.45 squared. So that was going to give us our R there, just like that, actually. Okay, just like that, guys. So this is 89.063 kilometers per hour, the same units. Then the theta, the angle between there, that is theta being arctan opposite over what? Adjacent. So that's arctan of the vertical, 53.45 over the horizontal, 71.241, all being positive. Remember, these must be positive. So calculating this, it was going to give us 36.88 degrees. That is from east to the what? To the south in terms of the direction. East to the south. Where theta is, it's inside the triangle. East to the south. That's your direction. You must start from a line like this, from a line. You don't just start from the air from here, guys. You are starting from here to where? Here. It's south going the east way, or we are starting from the east going the south way. That is how you take your answers. Not to start from here like you're moving from the air. No. So therefore, our resultant velocity was going to be what? 89.063 kilometers per hour at what? The theta, the angle, that is east to what? East to south as we move from this east line going this way. We are going where? To the south. So that's east 36.88 degrees to the what? To the south. Or we can move from the south going to the east, but you can call that one alpha. So you subtract, just like the previous case, guys, 90 minus this. So if you want to use that one from south to east, you're going to use it, guys. You're going to subtract 90 minus 36, guys, something like that. Then you find your answers. All right. So I want you to do that for the sake of time, guys. I'm not going to subtract, guys. Okay, this is too much. But you can do that. All right. Just like that. Just like that. Just like that. So I want those who are using actual angles here. Those who are using actual angles. Are we together? Are we obtaining the same answers? You must have same values as this one. Same values. All right, then the last part was to calculate the displacement after 10 hours. So as you can see, it is just like the previous question. Displacement, velocity times what? Time. So we're going to take our resultant velocity that we calculated here, just like that. So that is B. So displacement is velocity times time. Remember, they said for what? For 10 hours. So our displacement, this is our resultant velocity. This one is, it is 89.063 times the time frame, 10 hours. So that was going to give us 890.63. This is kilometers, so it's gonna be in kilometers. If it was meters per second, you must use your time in seconds so that your displacement, your distance will be what? Will be in meters. If it is kilometers per hour, your time, hours, distance, displacement, kilometers. I explained that one. So in the same direction as what? As our resultant velocity, meaning to say it is going to maintain what? Same direction, just like what we had. Okay, so like I said, guys, this is the most important part here of our question, where the direction seems now to be different at all to what we had, I mean, in terms of the presentation. There they are saying, I want us to be careful with our question here, because I explained this on our introduction, but just going to give more emphasis there. They're saying a ship sails at 20 meters per second in this direction. So this is of the ship. All right, 20 meters per second east, 30 degrees to the north, and experiences a certain current of 10 meters per second. This is its speed. Flowing, take note, not flowing in this direction, flowing west, no, from here, from this direction. So the current that we have there, it is of a speed of what? 10 meters per second from, not in this direction, but it is from that direction. From that direction. That is the most important part of our question here. From. So when it is like this now, what are we going to do? Remember, from this part that I was introducing, all right? I can even just try to remove this so that I just show you straight the notes and the question. So let me just try to do this quickly. Let me just remove this one. It's not going to affect. Where are those notes? Here. All right. These are the notes that we have been talking about. So we can see that here. Remember what I was saying. Flowing in the given direction, you take as it is. But when a current is flowing from a certain direction, from a given direction, from that part, from, you must continue with it to the other side. You extend that current to the other side. Simply extend the current in this case. Simply extend the current. Simply extend the current. Apply your components as usual from that direction. Guys, this is the case. So it was supposed to be like this. All right. Let's quickly have this, guys. This is north, south, west, and or east. So the boat east to what? East to north. From east going to north, east going to north. This is our direction. This is of what? The ship, I mean, which is 30 degrees there. From east to what? To north. We are moving from east going to the north direction. So that's it, guys. 20 meters per second. That's our ship. Then the current is from here, west 20 degrees to north, west like this, west 20 degrees to the north. It's from that part, from here. So what are we going to do with this? We continue with that current to the other end. We put it there. That is the condition. So in between west and going to the north, from west going to the north, the angle there was what? 20 degrees. So using, guys, our vertically opposite angles, you can see that also this angle is going to be what? 20 degrees here. So that is it, guys. So this is our current 10 meters per what? 10 meters per second. This is the condition when it is from. Otherwise, guys, everything remains the same, meaning to say this one is no longer useful. We are now focusing on what? On this other side that is remaining. So from the other side, guys, using your method, are you going to take the angles, the actual angles, or using the reference angles on your components? Or are you going to use the actual angles? Guys, it's your components. Use the way that you understand. So as for me, I'm going to work with the reference angles. So our horizontal component to the right-hand side, we know that they are what? Positive. So that will be 20 cos of 30 plus 10 cos 20, 10 cos 20 degrees. These ones, they are positive to the what? To the right side, the horizontal components. So that was going to be 26.717. Remember, meters per second. So this is meters per second to the what? East. Horizontal being positive, it means you are going to the what? To the east. Then we do the same thing for the vertical. But as for our vertical on top, above, we know that it's positive. All right. Below, it's what? Negative. So it's going to be 20, which is positive. Sine of what? Sine of 30 degrees. Then to the down here, I mean in the down, it's negative. So that's negative 10, negative 10 sine what? 20 degrees. Sine 20 degrees, just like that. So combining everything, guys, this was going to give us the vertical component, and it was going to be 6.58 as a positive. Vertical, positive, we are going up to the north. Just like that, guys, we are done. With this information, we are done. You compare now to the what? The triangle, that which quadrant that carries the east and the north at the same time. There's only one. There's only one. Which part is that one? Which part? North and east. North and east here. So this is where we're going to have what? Our resultant. Just like that. So guys, I hope in any question that is of this nature that you are going to have in exam, you are going to answer it, guys. This is the same simplification that you're simply going to use, just like that. So you're back, your resultant, guys, everything as it is, 26.717 squared plus 6.58 squared. So that was going to give us the resultant of what? 27.515 meters per second. And our theta, opposite of adjacent, opposite adjacent there. So it's arctan, opposite adjacent. So our theta was just going to be arctan of the vertical 6.58 over what? 26.717, like that. So this was going to give us the angle, which is our direction, 13.836 degrees. Moving from where, as we are considering this quadrant, from east, this is the line that going to where? East to north. Or you can take this one from where? From north going to east. So it will be north. You use this angle alpha if you want to take that angle alpha. All right. So it will be north alpha degrees to the east. But you must calculate that. All right. In our case, guys, we calculated theta. So we're going to use that east to the what? East to the north. So this is east to the north. So therefore, our resultant velocity was going to be what? 27.515 meters per second. Then, like I said, we are moving from east going up to the north, east to the north, according to this theta that we calculated. So that's at east 13.836 degrees to the what? To the north. Just like that. So I want you guys to go through questions as much as you can of these typical questions. And if there's a certain section of your guys, you're the one who's doing engineering science, guys. Let me know any section that we think we can put more emphasis on, and also doing more questions on that section, which can help you to answer your questions. Like I said, engineering science N4, it's actually a lot of things. But as an individual, try to do as many questions as you can. Work more question papers. Try to figure out how questions are being given and do as many questions as you can. So that's it, guys. Till we meet again.